All right, today's topic is on transformations of quadratic functions. So what I mean by that is when you have a quadratic function, meaning you have something that's just x squared, right? And when you graph it on a graph, very basic, you have something like this where it's a parabola that opens up on a graph, right? So what the transformation part comes into it is moving our parabola around the graph and what equations we need to make it move to where we want it to go on the graph, okay? So very simply, we have x squared. X squared is we're going to call that our parent function. Okay. So that's the parent function. So that's what I just said. So it's x squared. It's your basic graph where it's just like I said before. It's just a parabola. It's sitting right here in the middle of the graph. Its vertex is right here at 0, 0. It opens up. Okay. And that's kind of what we're talking about here. And so the transformation part comes, like I said, moving this around. So everything that we do is going to be based off of our parent graph here being in the middle of the graph and how we're going to move it from the middle, okay? So I'll show you how that works out with some of the equations here. So if we have x squared, right, as our parent graph, what if we were to add plus k, okay? Now, when we add this plus k, okay, what this means is we're moving this graph left or right. Sorry, excuse me. We're moving this graph up and down, okay, on the graph. So, for example, so what we're going to write is we're going to write it translates, okay, up or down. So it's going to tell us which way it goes. Is it going to go up on the graph? Is it going to go down on the graph? So basically, if k, okay, is positive, right? If k is positive, then the graph translates. Sorry, not enough room here. All right. So if k is positive, okay, then the graph. The graph translates up, okay? If k is negative, then the graph translates down. Okay, so very simple. So if we have that, right, and we give an example, so let's say if we do x squared plus 3, right, then our graph translates up 3. So what that means, if I were to draw this out real quick, so if I have x squared, right, x squared like that, right, as our parent function, if I did x squared plus 3, that changes it, where instead of it being, the middle of it being here, it goes up 3, like this, okay? So it's the same graph, right? It's just that this plus 3 means we're going to go up 3 from the middle of the graph. That's all that means, okay? Now, what if we changed it to, I'll leave that one there, to x squared minus 4, okay? If we had x squared minus 4, then this translates down 4, right? So once again, parent graph, right, we have our here. So we're going to go down 4, 1, 2, 3, 4, and down here, it's going to open up, okay? So that's what I mean by this plus k, translating up and down. This on the graph, right? If it's just like this, it's going to stay in the middle of the graph. It just tells us. If it's positive, graph goes up. If it's negative, translates down, okay? So now, what if, instead of having that, what if we had this? X minus h squared, okay? So when we have this, when you see this like this, okay, and this h will be a number, all right? This will tell us where it translates left or right, okay? So this tells us which way on the graph we're going to go left or right, translating, okay? So kind of the same as the last one, right? All right, you're right, if you know that. If h is positive, okay, then the graph translates left, okay? If h is negative, then the graph translates right. Okay, so quick example, right? Let's say we have x minus 2 squared, right? So we look, our h here, right? Our h is negative. Okay, it's a minus in front of it, which makes it negative. So if it's like that, it's going to translate to the right 2. Okay, so very simple. Here's our parent graph, right? Okay. If we have this, now from here we're going to go to the right 2. So 1, 2, and we're going to do this. Okay. So it just went right 2. So that's how that works out. Okay. So there's no up and down, right? In the parentheses like this, looking like this, it's a minus here. So we're going to go right 2. Okay. Now what if we had instead of that in the middle, we had plus 6, okay? Once again, now it's a positive, right? It's positive, so our graph is going to translate to the left 6. So now, here, we're starting in the middle, we're on 1, 2, 3, 4, 5, 6, right? And that's where our graph is going to open up from. There, okay? All right, so now if we put those things together, right? And if we were to add this here, it would be like this, okay? So it would be x minus h squared plus k. Remember, here it tells you left and right. There it tells you up and down, okay? So if we had this, x minus 4 squared plus 7, what is this going to look like? Well, what's the translation going to be? Well, if we look in the middle, right here, it's a minus, this is our h part here, right? So this is a minus 4. So it's minus, we're going to go to the right 4. And here it's a plus 7. It's positive. So it's going to go up 7. Okay? So that's how that works. We can kind of put it all together like that. Alright? Alright, let's add another element to it. So we have our base here, right? What if we add in the front an A? Okay. Now here, this tells us, okay, how our graph shape is going to look in terms of being wide or narrow or how it's going to look up and down, okay? So now, here, if A is greater than 1, is greater than 1, okay, then our graph, A is greater than 1, then the graph is narrow. Okay. If A is less than 1, then the graph is wide. Okay. If A is positive, then our graph opens up. If A is negative, then you guessed it, our graph opens down. Okay? So I know, it's a lot of rules. This is a whole lot of rules here. I understand, but it's kind of, but this whole thing is just like, hey, what's the rule for this? Oh, this is what it is. So you just kind of have to know these rules. Okay? So let's do some examples here, right? I'm gonna leave this up here just for reference. All right? So what if we had 3x squared? Okay, just a simple, let's just make this our a, right? So I'll write it up here. A x squared, okay? This is just a very simple thing to kind of show you what our a is going to be, okay? So our a is going to be our first number here, okay? So remember, so a here, a is greater than 1, right? So our graph is narrow, all right? And a is positive, so our graph opens up. Okay? So greater than 1, narrow graph, positive, opens up. Okay. What if we had 1/4 x squared? So now our graph, our a is less than 1, right? It's a fraction. If it's a fraction like this, it's less than 1. So it's a wide graph. Still positive, so still opens up. Okay? Negative 2x squared. So now our a is, well, so if our a is negative, right? So our a is going to open down, but look, it's still greater than 1, okay? So it's going to be a narrow graph, narrow, and it opens down because it's negative. Now I know technically negative 2 is less than 1, okay? But when I talk about basically the absolute value of it, okay? So basically it's not a fraction in the sense of like, it's the absolute value of 2. It's not necessarily, negative 2 itself, right? That negative doesn't go with the 2 per se. It kind of just shows us if it's up or down. Okay, if it's positive, it goes up. Negative, it goes down. If it's this fraction less than 1, it's wide. If it's a number that's greater than 1, either one, it's going to be a narrow graph. Okay. And then finally, we have negative 1/3 x squared. So now we have a negative, and it's less than 1. So it's a wide graph. Wide graph opens down. Okay. So what if we put all of this together? Okay. What if we put all these rules together to figure this out? So all the rules together that we just wrote down. Okay. Here's our thing. I'm gonna write this down here, right? So A says wide, narrow, and then upper. You know what? Don't do that. Let's not do that. Okay, I was going to confuse you all. You're already confused as this. Don't do that. No. Okay, so let's just go through it. Okay, let's give an example, right? What if I gave you this? What if I said 4x plus 4 squared minus 3? Okay, so let's talk about what this graph does. Okay, so first, let's look here. Okay, our translation, right? What's our translation? Let's look in the parentheses. So I translate. It's a positive 4, okay, which means we're going to go left. So it goes left, 4, right? And then outside parentheses, it's a minus 3. So it means it's going to translate down 3, okay? So now we've shifted our graph to the left and down, okay? Now look in front. Number in front, we have an A in front, okay? It's 4. It's a positive 4, okay? And it's bigger than 1, which means it's going to be a narrow graph, all right? So it's narrow, and it's positive, so it opens up. So what really does all this mean, okay? So if I took a graph, let's just draw a simple graph, okay? If my parent function was like this, actually I'm going to draw two, okay? So I'm going to draw my parent function, right, in the middle, just like this, right? Now let's do everything it says here, right? So I'll draw another graph, okay? I translate left 4, down 3. So if I start in the middle, I go left 1, 2, 3, 4. You don't have to do this. I'm just showing you how this works, okay? So left 4, down 3. So left 4 and then down 1, 2, 3. So my vertex is here. It's left 4, down 3. This is where my graph is going to, the middle of my graph is going to be, okay? My axis of symmetry will be here, okay? Now, it's a narrow graph, it opens up, okay? So it's positive 4, so it opens up, and it's going to be narrow. So if this is my parent function, it has to be narrower than that. So we're going to do this. Okay? Something like that. So see how it's not as wide as this one here? I mean, wide like this, the shape of it is not, it's not as wide, right? So it's more narrower, right? It's compressed, right? And we shifted it, we've translated it to the left and down. It's wide, it's narrow, and it still opens up, okay? So that's why we moved this graph, all right? So like I said, when I ask you to do these things, you don't have to worry about drawing the graph. I just want you to know what it does, what it actually does, okay? All right, so one more example here. All right. Let's do x minus 5 squared plus 6, okay? So if I do this, all right, we have translates, all right, look in the parentheses, it's a minus 5, right? So it's going to go to the right 5, and then look here, it's plus 6. So it's going to go right 5, up 6. Now a in front, is there an a in front? No, okay? So our graph will stay the same. It's going to stay the same. It's not going to be any narrower or wider. It's going to be the same, right? And it's going to go, and because there's nothing in front, it's going to automatically open up. Okay. So that's how that works. So it's just about knowing the rules, knowing to figure out what each thing means. All right. I know it can be confusing, but once you have these rules kind of written down and figured out, you just have to find, oh, it's this and this. Oh, okay. It's negative, goes right. It's positive here, it goes up. There's nothing in front. All right, same, it opens up, right? It's just kind of one of those things you just have to know. Okay, so those are the rules, transformations of quadratic functions.